Mechanism of formation of Schiff's base. Continuation of the previous lesson. Let us see the matter in detail. Mechanism of formation of Schiff's base. First of all, let us see what are imines. Imines, compounds with carbon-nitrogen double bond. Organic compounds with carbon-nitrogen double bond are called imines. The simplest imine is this. Its name is methylene imine. Compounds with carbon-nitrogen double bond. What is Schiff's base? Schiff's base. Carbon-nitrogen double bond. Here, alkyl group or aryl group, but no hydrogen atom. And with these hands, here, phenyl group and hydrogen. Compounds with this structure are called Schiff's bases. Schiff's base is prepared from aromatic aldehyde and aliphatic or aromatic primary amine. But here, no aliphatic aldehyde is used. In this lesson, we are going to learn mechanism to prepare Schiff's base from aromatic aldehyde and aliphatic or aromatic primary amine. At the same time, we will learn why aliphatic aldehyde cannot produce Schiff's base. So, let us see mechanism in detail. Aromatic aldehyde is used to prepare Schiff's base. Aromatic aldehyde. With this, primary aliphatic amine, suppose methylamine, and aromatic primary amine, suppose aniline, is used to prepare Schiff's base. When benzaldehyde is treated with methylamine, then water gets removed and condensation product is obtained. Schiff's base. Its name is benzyl methylamine. Benzyl methylamine. This group is known as benzyl group. So, this is benzyl methylamine. When benzaldehyde is treated with aniline, aromatic primary amine, then water gets removed and this condensation product is obtained. Carbon-nitrogen double bond. Here, phenyl group, a kind of Schiff's base. Its name is benzyl aniline. This is benzyl aniline. When nitrogen is bonded to phenyl group, then this is specially called anile. So benzyl aniline is a kind of anile. Here, Schiff's base. These compounds are known as Schiff's base. Why it is base? We know nitrogen contains free pair of electron. Because of this free pair of electron, according to Lewis concept, these compounds can donate this free pair of electron. So, according to Lewis concept, these compounds are known as bases after chemist Gilbert N. Lewis. Now, mechanism of the reaction. Benzaldehyde. What does this ring mean? This ring means movement of pi electrons, circling of pi electrons. Because of the circling of pi electrons, phenyl group achieves electron pooling character, electron withdrawing nature. But if we use aliphatic aldehyde, this is methyl group, electronegativity of hydrogen is 2.1, but carbon 2.5. So electrons move towards carbon. Finally, carbon pushes electrons to this carbonyl carbon. That is, methyl group has positive inductive effect. Again, methyl group pushes electrons to the carbonyl carbon through hyperconjugation. It has been discussed in detail in toluene. That is here. Phenyl group is electron pooling group, but methyl group is electron pushing group. As a result, when oxygen becomes negative in charge, carbon becomes positive in charge because electronegativity of oxygen is higher than carbon. Carbon becomes partially positive in charge because of the highly electronegative element oxygen. Again, carbon is bonded to phenyl group, which also is a kind of electron withdrawing group. So here, positive charge density on the carbon increases a lot, but in case of aliphatic aldehyde, negative in charge, positive in charge, due to the presence of electron pushing methyl group, positive charge density of carbonyl carbon decreases. That is why here aliphatic primary amine, which acts as nucleophile, and this nitrogen of this amine can attack this carbonyl carbon very easily because this carbon is highly positive in charge because of the presence of phenyl group. But here aliphatic primary amine, this nitrogen cannot attack this carbonyl carbon because positive charge density of this carbonyl carbon decreases a lot. That is why here this amine cannot act as strong nucleophile, but here this amine can act as nucleophile and can attack this carbonyl carbon very easily. For this reason, aliphatic aldehyde cannot produce Schiff's base, but aromatic aldehyde can produce Schiff's base in this way. Phenyl group, carbon, oxygen with negative charge. Here hydrogen, this hydrogen. Then nitrogen forms bond to this carbon. Hydrogen, hydrogen. Methyl group, as here nitrogen donated its pair of electron to this carbon. Over nitrogen, positive charge develops. Now, because of this positive charge, covalently bonded electrons of nitrogen and hydrogen changes to lone pair of electrons of nitrogen again, like this, and this hydrogen gets free as proton. This proton combines with this oxygen, which is negative in charge. Now this is obtained. Lone pair of electron. Here oxygen is a highly electronegative element, so this bond, carbon oxygen bond, undergoes heterolytic fission, and here hydroxide ion gets free, and around carbon electron deficiency gets created. So nitrogen hydrogen bond shifts here to form carbon nitrogen double bond. This hydrogen gets free as proton that combines with hydroxide ion to form water, and finally this is obtained. This hydrogen, carbon nitrogen double bond, nitrogen with methyl group, Schiff's base, water gets free. So this is condensation product, which is formed through elimination of water. This is Schiff's base. Mechanism of formation of Schiff's base and why aliphatic aldehyde cannot produce Schiff's base. Thank you for watching.